More and more children are out of school, but parents don't want math learning to stop. They're turning to Mathnasium at home. Real-time math instruction tailored to your child's exact educational needs. It's the same face-to-face live instruction used in our centers for over 15 years, now on a computer. Your child can keep their math skills sharp, catch up, or soar ahead, from home or anywhere with an internet connection. To learn if Mathnasium at home is right for your child, visit mathnasium.com/at-home. Mathnasium at home, changing lives through math.
Hi everyone, welcome back to Mathnasium Schoolhouse. My name is Sandra, of course your instructor for today, seeing as we're doing and working on part 2 of our If This Then That Schoolhouse series. We had one lesson yesterday, which we'll briefly review in just a few minutes. And so we'll be continuing from where we left off there. If you were not able to join us, you might decide it's most helpful if you pause right now this video and maybe go back to part 1, or if you feel that you can easily follow along with us today and then maybe after this lesson is done, go back to part 1. I'll leave that decision to you, but just so you know, we are working off of where we left off. And what I mentioned yesterday is, as funky as this title is, If This Then That, which some of you might be familiar with that language, maybe where it fits into your math studies or your computer science studies. I'll give you a little hint there. I talked about that connection yesterday a little bit. But this, of course, is part of a larger conversation, which is logic. Logic is important in mathematics when you go on to study it further and further, making sense of the decisions you make, seeing it in proofs and whatnot, just a lot more complex. So getting us slowly starting to think that way is super important. And then as I hinted at yesterday, it shows up quite a bit, a lot, I should say, in coding, in programming, namely in instructing a program as to what it is that you want it to do flawlessly as much as possible. So we'll continue with that. I will follow along with where we left off with yesterday's worksheet. So there's just 2 questions I want to address there just to summarize what we did. And then I'll carry on with today's follow along worksheet, which should be shared with you. So you can pull that up if you feel that that is more helpful for you. And don't forget that here we're working off of Mathnasium Schoolhouse lessons. It is different than our Mathnasium at Home program, which is where you follow along with your customized, individualized learning plan, where we see where you are with your skills and we work from there. And so this might be a topic that you might ask your instructors. You know, you might tell them you're super interested in it, and so this might be something that they add on to that learning plan if you're interested in learning more. So don't be afraid to reach out to your Mathnasium for more content on this, especially when we end off for today. I'm going to pull up my whiteboard here. Hopefully you see that now. I've just prepared it in advance of this lesson, and I've just prepared it with 4 key terms that we learned yesterday. Maybe learned, maybe revisited, depending on where you are in your math journey. These are key terms in our exploration of logic. And so we looked at what does that original statement look like, that original conditional statement. And we'll kind of use the syntax that we used yesterday in just a bit. We looked at then the converse of that original statement. What does the inverse look like? What does it mean to take the inverse of that statement? And then also the contrapositive. So we'll work off of this knowledge from yesterday. We'll fill in a little bit more before we carry on. So what did that original look like? Well, we can write it a few ways. I'm going to write it here just like this. I want to keep this on the board for as long as I can. So if P, then Q. Again, we introduced these variables yesterday. They tend to be the 2 variables you'll see being used in these logic conversations in mathematics. Really doesn't mean anything to us that it's P and Q, except that what they stand for is important. P is our hypothesis, Q is our conclusion. We used this yesterday in a lot of our problems. If the hypothesis, then the conclusion. And that was just the original statement being made. And we can write it different ways as well. The converse was, we can think of it as just switching it around. If Q, then P. So I'm going to write that here just to remind us of that. The inverse, we talked about negating a statement. So the inverse looks at negating it. So the way that that looks like is if not P, we saw this symbol being used yesterday, then not Q. And the contrapositive, even if you didn't join us yesterday, you might be thinking, okay, I think I get some sort of pattern here. With the contrapositive, we both switch and we negate. So if not Q, then not P. All right. We also ended yesterday's lesson with if and only if statements. Again, you can revisit that if you're interested in learning more, but that was another thing that we added in there. And then a little bit of some observations with the relationships between these, which we'll continue to go through today. All right, so there is that. So what I'm going to do now is pull up that last little bit of the follow along document from yesterday. I want to apologize once again. My comments aren't refreshing for me as much as I'd want them to. So if I don't call out your name and thank you for participating, I want to apologize in advance. I'll try to do my best here and there. But nonetheless, I do encourage you guys to participate and help each other out to build a nice sense of community. Make sure we're all comfortable, we're all learning here, we're all having fun. So let's make sure we stay on topic and focus on what's being taught today. So, without further ado, I am pulling up page 2 of yesterday's document, the last 2 questions there, 8 and 9, just to revisit, and then we'll move on to some new content for today. So let's look at this here, and the original question was to find, of the original that's given to us, find the converse or write the converse of it, the inverse, and the contrapositive. So we're going to do that right here. So for question number 8, our original statement says, if it does not rain today, then I go for a walk. If P, then Q, which means that P is our hypothesis, which is does not rain today. And Q is our conclusion, which in this case is go for a walk. All right. So let's talk about the converse. It was the switching around. And so I'm just going to put C-O-N here for the sake of space. If I walk today, if I go for a walk today, I should say, you know what, I'm going to keep some short forms here. If I walk, then it does not rain. All right, just switching it around. No negating just yet. Then I want to look at the inverse. I'm just going to put IN there for that. Inverse, we talked about negating it. So I know you can't see what's on top of this right now, but what we had written was, if not P, then not Q. So without switching things around, we're simply looking at the negating if it does not rain today. And yesterday we had said that another way of looking at negating something is looking at its opposite. So what is the opposite of does not rain today? If it does rain today. And so we can write if it rains, then the opposite, because we're negating of that second part, the opposite of going for a walk is to not go for a walk. So if it rains, then I do not go for a walk. I'm just going to put 3 dots there, but just notice what we're doing there. So if and then, but we're just kind of changing up the language there to satisfy the different statements. And then the contrapositive, we said, oh, that puts together both ideas, which is the switching and the negating. So let's look at that. Okay, so we've already switched it in the converse, and now so we can take that and then just negate it from there. So we would have, if I don't go for a walk, let's see if I can squeeze the rest in, then it will rain. All right. We'll do another one in just a few seconds, just to double check that you understand what's going on. But again, this is everything that we looked at yesterday. Taking that original, writing it as an if-then statement, then looking at rewriting it in its converse form, its inverse form, and its contrapositive form. All right. Let me scroll down to question number 9. Let's do that as well. If it shows up for me. All right. Got a really mathy one here. So our original says, if a figure is not a polygon, then it is not a triangle. Right now, we're not focusing on whether these statements are true or false. We're simply writing them as the converse, the inverse, or the contrapositive. So let me erase this and let's go through that pretty quickly. You know what, maybe I'll just even say them out loud here rather than writing it. So what would the converse look like? You can think of that for a few seconds before I say it. Once again, the converse looks at switching it around. Okay. Let me double check the comments while you guys maybe think of those three. I think this is a good opportunity to do that. All right, so while those load for me, let's see. So converse, if I just said that we're switching it around, simply put, if a figure is not a triangle, it is not a polygon. All I did was switch those two parts around. Okay? Next, if I have the inverse, which we talked about negating or looking at the opposite, and in math terms, in the notation that we looked at yesterday, we said if not P, then not Q. So we're not switching things around. So keeping the original statement as it is and just negating both parts, we can say if a figure is a polygon, because the opposite or the negative of not a polygon is to be a polygon. So if the figure is a polygon, then it is a triangle. That's the inverse. So we took care of those two. And what about the contrapositive? Well, let's switch and negate. So we've already switched it before with the converse, so let's start there. The converse, once again, was if a figure is not a triangle, then it is not a polygon. So negating those. If a figure is a triangle, then it is a polygon. And that would be our contrapositive. One more time. If a figure is a triangle, then it is a polygon. All right? Hopefully that makes sense for all of you that joined me yesterday, and if you didn't and you're still on board, wonderful, glad to hear. Once you get used and maybe you've worked on it enough, you'll just remember what each of these terms mean, and it'll be very easy for you to kind of manipulate that original statement to find what it is that you need. So that was what I wanted to work off of from yesterday's follow-along worksheet. Now, like I said, we do have a new one. So I'm going to scroll down in the PDF in just a second. Let me go back to my whiteboard here so you guys can see this. And I will prepare my second document here. You guys can take this opportunity to pull it up yourselves. Don't forget you have a practice sheet with every document that I share with you for my lessons, so you can always use that. And my intention is always, if you complete them, and you have questions or you want to double check your answers, your best way to do it is to reach out to your nearest Mathnasium. And as I always say, our instructors just adore math, and I know that they would be super excited to get a student in the center, a new student that just says, hey, I learned some math with you guys online and I want to just double check my answers, or I want to have a deeper conversation about this. I know that that would just thrill our instructors. So feel free to do that on any topics, especially that interest you the most. So this is the next document, the first practice page that I have available for you, and I thought this was a wonderful way to bridge together today's lesson, part 2, and yesterday's what we did. So here we're going to look at more relationships. Maybe some of them I'll skip so you guys can explore those on your own. There's 9 of them that I want you to look at. You're simply filling in the blanks with original, converse, inverse, or contrapositive. So I'm not expecting anyone to know the answer right away. With some of these problems, you might choose to go back to the problems we just completed and think of specific examples, and then think of what that result will be. And there's absolutely nothing wrong with that. So for example, in question number 1, you're looking for the converse of the inverse is the. So what we might choose to do is go back to one of our examples from before. So let me just pull one up here. We just had, let's use the rain one and the walking. So we had, the converse was if I go for a walk, then it will not rain. Then the inverse was, if it rains, then I will not go for a walk. Here we're being asked to find the converse of the inverse, which means we're switching, because that's what the converse does. We're switching something, which is the inverse, but the inverse was already negating both that P and the Q. So another, and I know that sounds complex. I'm getting somewhere, I promise. Because another way, if you don't want to jump to examples, but again, it's fine. It's a great start to thinking about these, and it's absolutely something that I would have done as a younger student. Now I'm a lot more comfortable with notation, so another way you can do it is, if we're looking at the converse of the inverse, let's start with the inverse. The inverse says, if not P, then not Q. To take the converse of something like this means to switch. So now the statement that we're working with is, if not Q, then not P. And this should look familiar to you. I'll give you a second to think about what that means to you. And actually, I'll give you a hint. You can take a look here. You should spot it. You should say, no, 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 aha. This, what Sandra just boxed in, is exactly what the contrapositive says. So the answer to this is the converse of the inverse is the contrapositive. Pretty cool, right? Pretty cool when you start to put a lot of notation together and you can actually read it because you understand the relationships and you understand the meaning behind these words that we're using. Let's just do a few more together. Erase that. So let's jump to number 2. The converse of the contrapositive is the. Again, you might choose to go back to questions number 8 and 9 from yesterday. We just completed them. You have the answers with you. Use those examples. Use your knowledge of the converse to take the converse of that contrapositive we had found together. That's one way. Another way is to write down the contrapositive first, which says, if not Q, then not P. I'm really asking your math minds to really dig deep today, but I promise you it's worth it to get used to thinking this way for math, your math studies. So this is the contrapositive, if not Q, then not P. The converse, as I keep on saying, simply says to switch it, and so you would actually say, let me show the switching, if not P, then not Q, and that should look familiar to you because that is the inverse. Again, I'll show you my whiteboard from what we summarized earlier. It's exactly this one here. If not P, then not Q. All right, let's do 2 more together. I'm going to jump to the bottom of that sheet, that page, because I have a few more things I want to look at today before we end off. So I'm going to scroll down to the bottom and show you questions number 8 and 9. So there are 9 of them. Again, I really challenge you to think of them, especially if you're super comfortable with all the content we've seen up until now. Number 8, the contrapositive of the contrapositive. Whoa. The contrapositive tells us if not Q, then not P. In other words, it switches and negates. So what do you think happens if we switch and negate again something that's already been switched and negated, if that's a word? And hopefully you're thinking, wait a second, we've just essentially undone what we did. We switched and we negated, so we switched and took the opposite. So to switch again and to take the opposite again just brings me back to the original. Yay. And I'm going to keep that on there because actually, without us actually working through questions number 7 and number 9, those 2 answers are also the original. Not just because you're doing the converse of the converse and the inverse of the inverse, it's coincidental that when you do it, it's kind of coincidental, but it's also purposeful because let's think about the converse. We just talked about it. The converse of the converse already switches, so if I switch one more time, and there's only 2 options, I'm back at my original. Going to number 7, the inverse just negates, which takes the opposite. And since there's only 2 options in taking the opposite of something, I've taken the opposite, then I take the opposite again. Okay, I'm back at my original. So questions 7, 8, and 9 all have answers of original. Again, if that was a little bit too challenging for you, if I jumped too quickly, think about that a bit more deeply afterwards, and I'm sure you'll understand completely. Or jump to examples. That could be another great way as a starting way for you to understand some of this logic. All right, enough about that. We have a few more questions I want to look at, and this looks at truth tables. So the next conversation that you would have in a class where you're learning a lot more in depth about logic is looking at the different options you have, the different truth values that can come up between different statements and the relationships between those statements. And we'll take a look at two types of those relationships. So let me scroll down here while I have this document open. And let's look at question number 10 here. This is what a truth table is. This is what it would look like if you're seeing it. Sorry, I'm just gonna pull this up here and draw maybe in a bit number 10's table here. But what are we looking at? Without having exact examples of what P is and what Q is, although we can absolutely come up with statements for those to follow along with some example, what we're looking at is showing the different options for P, the different options for Q, and then the relationships between them, because then we're going to do stuff with those. Okay? So for example, I could have, before I even jump to number 10, I could have a truth table that looks like P and not P. Very simply put, P has only two options. It can be a true or it can be a false. Not P is the opposite, so the opposite of true is false. The opposite of false is true. So these are my options. I can have true and false, or I can have false and true, because this always has to be the opposite. So I can't have true and false as well. Okay? If we jump to number 10 here, the chart becomes slightly longer. And why is that? Because Q is allowed to take on the same truth value as P. It's not looking at not P, it's looking at just another statement. What I mean by that is, I'll do this one together, and then I'll let you try out number 11 on your own. If I have P, just draw it slightly higher up here. Let's look at the options for P. It can be true. Q can also be true. So we can have both of them true. Eventually I can also have P be false and Q be false as well. It can happen. What happens in between there? Well, P can be also true, but Q can be false. And the other way around, false and true. Okay? And again, you can come up with different scenarios as to what your P is and what your Q is if that's more helpful for you. Okay? So let's observe a few things here, and maybe it'll be easier for you to understand why these charts grow longer and longer the more statements that we have. Because if you look at number 11 already, it's a bigger chart we have to fill out. But there's also 3 columns, which also means to us 3 statements to take into account. So one observation I want you guys to make is, how do I know how big this chart has to be? How do I know how many combinations there will be? So going back, actually I want to keep this one on here for just a second. P originally had 2 options in our P and not P chart. If P has 2 options, okay, there are 2 possible combinations that we can have there. If I have 2 statements, which is my P and Q here, let me show this like this, 2 to the power of 1. That'll be easier for you to see the pattern here. 2 statements, that means I have 2 to the power of 2, which is a 4. In question number 11, you see that I have P, Q, but also R. I have 3 statements I'm working with, and so I need to see how many combinations are possible. Well, that's 2 to the power of 1, 2, 3, which is 8, which is why you see in the entire chart there are 8 rows to fill out with combinations. And let's look at those different combinations really quickly. I'm going to erase this. I won't be able to fit it into one chart in the spacing that I have, so I'll break it up into two options in just a second. And I'll just write out what we have. And maybe I'll do that in green. So let's do this fairly quickly. We can have, of course, all of them be true. Wonderful. We can have only the first two be true and the last be false. We could have then first P be true, Q be false, and R be true. Then we can have P still be true. We can have Q still be false. And we can have R be false. And you can verify that I did that correctly on your own after or right now if you want to think about it. Then continuing the chart, what would be normally at the bottom here, I'm just going to continue on the right over here. Then we can have P be false all the way down. We've exhausted all its options when P is true. We can have Q be true for the top two and false for those bottom two. And then kind of switching things up for R, we can have true, false, true, and false. And so altogether, there are 8 combinations to be made. And again, we won't spend too much time verifying that that's true, but I challenge you guys to do that and verify that what I did on my whiteboard right now is in fact true. These are all the combinations that we could have with these statements, no matter what the statements are. They can be true or false. What do the combinations look like? And that is what is called forming and putting together a truth table. I'm going to scroll down here to the second page of today's document, and although I won't have this on the screen all the time, we are going to use these statements, S, T, U, V, W, X, for the next few problems before we end for today, to both provide us examples and some context to these statements that I use, and talk about some more relationships we can have between statements. And one of which is conjunction. So I'll get to 2 of them here, and then we'll use them in the next few problems. All right, so we can have conjunction, and we can have disjunction. All right, conjunction is essentially looking at and. We're going to use the symbol kind of like an upside down V. And for disjunction, if you would already guessed, it's or, and we're looking at P or Q shown that way. Oops, did I do that wrong? I did. It's an actual V. Not an actual V, I should say. It looks like an actual V, the symbol itself. Okay, so those are the 2 relationships we'll look at. We'll keep this in mind. Maybe I should have added it to my notes at the top. That's all right. I can't see them anyways. So let's look at that. For example, if I told you to look at, you know what, we have one here, rather than me coming up with one. If we have not T and W for question number 12, not T and W, what does that mean? Well, we have, let's scroll up to T. T is Rian does Tai Bo early in the morning. So not T is the opposite. Rian does not do Tai Bo in the morning. And, I think we had W there, yeah. And Shadat is buying toe socks. Rian does not do Tai Bo early in the morning, and Shadat is buying toe socks. And what if I wanted to look at disjunction? So that's question, I'm going to skip 13, number 13 for just a second. For example, number 14, we look at disjunction, U or V. So jumping up to my context, my statements at the top. U says, Kyle likes to play the bongo drums, or Jason likes to play the double-necked guitar. Pretty simple, right? Pretty simple to write down how the statements relate to one another. Maybe not as simple to see them in a truth table, but that's where practice comes in handy. So let's look at this. I had an example prepared, but let's just jump to the exercise. I don't want to take up too much of your time here. So let's look at question number 13. So this is where we're looking at conjunction. How do I know that? I can see it in the chart. I'm filling in, yes, the column for not V, but I'm also filling it in for not V and W. So we'll fill in those truth values in just a second. So let me prepare that. It's just 4 rows, so I can easily fit it in here. While I'm doing that, you guys might want to try it out on your own, rather than waiting for the answers. So let's start filling things in. I'm just going to fill it in with what we already know, which is all the different combinations for V and W. We can have true and true. We can have true and false. We can have false and true. And we can have false and false. Everything we've already explored together today. So let's fill in the column for not V. Well, that's just negating, or in other words, the opposite of V. And we briefly talked about this yesterday and earlier today. The opposite of true is false, the opposite of true is false, the opposite of false is true, and the opposite of false is true. All right. So the reason we filled this in first is because we need that information when we look at these and statements. Now we're looking at not V and W. Okay, false and true, we get false. False and false, false. True and true, okay, true. True and false, false. And I believe in the practice page that I've left you with, I ask you to explore and verify first what we do here, and then explore why that makes sense. But all that I did was look at the relationships that they asked me to. And again, on this practice page, you can definitely, before you fill this in on your own or verify that it's true, scroll up to the top and look at the scenarios. So for example, if I'm verifying the false, let's see. Not V statement would be, Jason does not like to play the double-necked guitar, and Shadat is playing toe socks. All right, so we have a false statement. Let's look at then number 14 and we'll be done for today. Number 14, I believe number 15. There we go. Another chart with 4 rows, so let me prepare that for myself. Maybe I'll allow you guys to try that out on your own while I prepare my own board here. And here we're, of course, looking at disjunction. And we're required to have not V and not U. So I've just kept the values that are given to me. So now I look at not V. We talked about that really quickly before, so it's just the opposite. So I'll fill that in really quickly. False, true, false, and true. Again, just the opposite of what I have in my first 2 columns. And then I look at the or statements. So I look at not V or not U, which is looking at these 2 here. So false or false, of course we get false. And then keep going. So false or true, true or false, true or true. And I'm just filling in the truth values for those statements. Okay, again, I know I'm repeating this, but I guarantee it'll be a lot easier for you to see this when you add some context into the first few problems. So if I do that for myself right now, I'll scroll up to the scenarios here. First, I need to, in my head, think of the opposite of the statements to take them, negate them. So if I go to V and U, I think we did one of them earlier, yeah. Jason does not like to buy the double-necked guitar, or Kyle does not like to play the bongo drums. Okay, so I'm going to end it there just so you guys know in case you're not looking at this document yourself. I did mention it already, but at the end of here, I've given you another truth table to practice on your own, a slightly longer one with just a lot more options because there's a lot more combinations because there's a lot more statements. So in this case, we have 4 statements. You're going to fill those in. In fact, those columns are filled in for you. But then you also look at the relationships. So you're looking at W and Y, X or Z or Z, and then getting a lot more complex, but seeing how comfortable you are with putting together a lot more of those and or statements together. Looking at that relationship there, which is where you rely on those previous 2 columns to help you out. But once you've filled those in, that last column should be a lot easier. And then as I said, at the very bottom, I've also asked you, I can't scroll that far in my document, but I've asked you to observe some of those relationships and see when is something always true, or what is your outcome typically depending on the truth values that you have. Enough about me explaining it. How about you guys try that out on your own? I promise this becomes a lot more fun once you get a lot more comfortable with it. And as I said yesterday, there are so many logic puzzles out there for you guys to try out. And if you get really comfortable with this, comfortable thinking with this way, I promise it'll make you a very, very strong math student if you're not already there. I'm going to end it for today. Thank you all for joining me. I hope you join us tomorrow for a lot more Schoolhouse lessons with my fellow professors, Schoolhouse professors. I'm sure they're super excited to help you out with some more topics for this week. I'll see you next week, guys. Enjoy. Join us tomorrow. Smile a lot today. Stay safe. Bye-bye.
It's afternoons that seem to be the most hectic for us, so it was much more convenient when we found Mathnasium at home.
All right, so how do we do half of 5? I think one of the best things about at home is that it really feels like you're almost at home with the student in their house teaching them.
I'm in my comfort zone.
You can just ask for help and the instructor will come right to you.
With Mathnasium at home, I know that they're getting the help that they need.
Awesome, great job.
Mathnasium, changing lives through math.